Good afternoon all. Is it worth fixing this? It's a solar light which I bought, must be about 5 years ago now. It's quite a nice one. I bought it from Wilkinson's. I think I got 4 of these in total. It's got an amorphous solar panel on the top of this module here, which I believe has the battery in it. There's also a switch, an on-off switch there, which interestingly won't budge now. It's completely seized solid. Inside here there's a reflector, 3 white 5mm LEDs, and that's pretty much it. It doesn't work. None of these work actually now. They did last a lot longer than the solar lights typically do. They normally don't last much more than about a year, just to scrape through their warranty period. But these did 2, 3, 4 years. They've only just all failed. So what's actually gone wrong? I suspect battery is probably going to be a major part of the failure of this, but let's get this top section opened and take a look. Yeah, that's interesting. There's obviously a rubber seal there, rubber O-ring, which has which allows this thing to turn 90 degrees so that you can angle this solar panel on the top. That's clearly perished, and oh yeah, so it's just worked itself completely out now. So I mean, it would need a new rubber O-ring in there. I might have something in my O-rings collection. That doesn't look like it's going to leak an enormous amount, but yeah, so one of the failure modes of this is that the rubber parts perish. So I'm a little bit concerned about large insects wandering out of this when I take it apart, although maybe they would have done that already. What would be the point in living in here? It doesn't look like it makes a particularly good place to live. I'm not mad keen on insects, particularly the ones that move quickly and scurry about and surprise you when you're least expecting it. Right, let's see how this has fared in here. Not terribly well by the look of it. So the battery is a standard nickel metal hydride. Really need the camera to focus at this point. Sitting in a holder. The contacts of the holder don't look too bad, but what does seem to have gone bad are some of the connections on that circuit board. I suppose the first thing to do is check whether there's any juice in that battery. I can't imagine the solar panel would have failed sort of in and of itself, but maybe it's a connections failure thing. We've got some sort of strange tape. Seems like it's silicon sealanted down onto where the connections go to the solar panel. I'm not quite sure why that would actually achieve anything. I suppose the point is water's going to get in down this gap around the glass amorphous panel, and they don't want it running down through the holes. You can see a bit of sealant there. So I presume the wires were put through these holes and then sealant was just spread around there. But I'm not quite sure why we've got this plastic here. That seems a bit strange. Okay, I'll get my battery tester on that battery. So this is just one of these moving coil meter battery testers, which puts a modest load across the battery and then just measures its well, voltage, I presume. So let's dig this thing out, if it will come out. Perhaps I need a screwdriver for that. Okay, and see if it has any juice in it. No, it really doesn't, does it? Oh, hang on, that moved a little bit. But probably the connections are... Oh no, there is something. Oh, wait a minute. Yeah, that is juiced up. It's difficult to get a connection on there, but there is power in there, so why isn't it lighting the LEDs? There's a fair bit of corrosion on the negative terminal of the battery. I don't know whether that's leaked out of the battery. I would doubt it if it's still showing a reasonable charge. It may just have come off the coating on that spring, so the corrosion would be on that spring as well. So maybe I could just put that on a little sanding, a very light grey, fine-grained sander, just to get that off and see if I can get a connection on here. Now with the solar panel turned down and the light kept off it, that should switch the electronics on and light up those LEDs. So let's just give this a bit of a clean. So I'm just going to use this scouring pad. To start with, I'm just going to use it dry and just see if that's enough abrasion to get this muck off. Maybe it would be better wet. Yeah, I'm not sure how effective that's going to be dry. Let's try a bit of moisture on it. Right, a little bit of water on there, and I'm just going to rub it for a while on here. See if I can get a good connection on there. I'm not using any form of descaler, perhaps that might help. That does look better. Let's try it in the battery tester. It's quite difficult to get a good connection on here. But it does look like when I do get a good connection on here, it's actually showing quite a strong charge in there. So it must have been charging up to the point when all the connections went bad. Or maybe it's been charging all the time and the connection between the... Why am I not getting a good connection on this? That's driving me mad. But yeah, that's good. That's well into the green there. Does it light up the LEDs? Let's put it back in there and cover that up. No, nothing doing. That's not showing any glimmer of light from those LEDs at all. So there must be something else wrong with it. Right, I've been sort of scraping away at this board a little bit, see if I can get some of this corrosion off. That doesn't seem to have got these LEDs lighting up. The other thing I thought is if that switch isn't making a good connection, and I think we've got two large mounting points there and there. So with the switch in its position towards me, it would be connecting these 2 points together, and shorting those doesn't seem to make any difference to it lighting up, so it probably isn't the switch. Maybe it's these LEDs themselves. Now I was just wondering, to power these I'd probably need a 3-volt lithium coin cell. Could I put that on these connections without desoldering them, without risking damaging the chip or the board? I'm just interested to see whether those actually light up at all. Now, if I remember rightly, the circuit of a boost converter has a diode pointing at the load as the last part of the circuit. So that should work as an anti-backfeed diode if I power these LEDs up with a coin cell. So let's see if I can do that. So positive needs to go on this white lead. This is the LED, the lead running down to these LEDs. Negative needs to go down onto this common negative point down here. So let's get the negative attached onto there and dab the positive on there and see if these LEDs light up. Is that going to work? Can't see anything at the moment, but am I making a good connect? Oh, wait a minute. Yep. Yes, the LEDs are lighting up with that 3-volt lithium coin cell. So it looks like the LEDs and the wire running down to them is good. So is it the boost circuitry, the chip, or just more problems with this battery connection that's failing to step the voltage on this nickel metal hydride cell up to the 3 volts or so necessary for those LEDs? I don't know. Well, I suppose it would make sense to lift this board out if the screws will come out, and yes, they do seem to be willing to come out. That one looks like it's going to come out as well. And take a look at the other side of this board, because I mean, it's possible that the corrosion is so bad on the other side that it's not going to work at all. So let's see if I can get that turned around and visible. Yes, and there's some pretty bad rusting going on here. So it looks like moisture has sort of risen up through this switch housing, because there's no real seal around that, and got onto the steel casing of this switch and has just rusted everything from the switch itself right out to component leads like this inductor connection there, the connection on that resistor there, that capacitor, whatever that does. There's just an enormous, and that electrolytic there, there's just a huge amount of this rust grown on top of this switch, which is obviously why it no longer slides. It's totally rusted solid. So the point is, this circuit isn't working for whatever reason. Is that because the switch isn't making contact? I mean, I could very easily just solder across the relevant contacts of that. Or is it because one of these components has just been eaten away? Possibly a bridge between the connections of the capacitor, something like that maybe? Right, well, I was just sort of scraping rust off of one of the legs of this inductor here, and it just completely disintegrated away to nothing. So that inductor no longer has a leg on that side. So that's not going to work. And I've got a funny feeling I might have some of these axial inductors somewhere. So is it worth having a go at replacing that? Maybe it is. Yeah, in my sort of strange inductors drawer, I've got this. I mean, I've no idea whether it's the same value, but it might be worth just shoving it in and seeing if something happens. Right, so I'm just going to shove that across where the existing... Oh, look at that! That's amazing. That's where the existing inductor is. That made a connection briefly. Yeah, those LEDs have come on. So it is that inductor that's the problem. Well, then that's definitely worth welding, soldering, I suppose I should say, this new inductor in there, because that clearly works. That probably get this thing going again. Yeah, I think I'll do that. Yeah, I'm not sure how I'm going to get on soldering these wires with all this corrosion in place, but let's see how we get on. I'm using my old iron here. It's just quicker to set up than the temperature controlled one, but yeah, I'm having a job getting that solder to melt because of the corrosion on the old solder. Oh no, that's going in. Yeah, that's heating up. I need a means of pulling that inductor off the board now. Yeah, so it's a case of heating up that connection and trying to lever out the old component. Yeah, that's not working too well. Maybe I'll try using these reverse tweezers to hold the component while I heat up the pad. And I've got no solder on my iron, and try and extract it, but it doesn't want to come out, so maybe the corrosion is holding that lead in and it won't come out. Yeah, I really need 3 hands for this. Right, finally pliers on there, because that looks like the lead's been bent round. I do hate it when they bend these leads around. Ah, that's come out. Good. Okay, that's out. Let's put the other one in. Now, the trouble is the wire at the other end has broken off flush with the board, or corroded away flush with the board. So I'm having trouble pulling that out because I heat it up and then I grab it with pliers, for example, and it instantly cools down, and I can't pull that out. So I think maybe the solder sucker is the only thing I'm going to be able to use here. Let's give that a try. Heat that up and... Ah, yeah, that seems to have removed most of the solder from there. And yeah, there's the little remainder of the component leg that was in that hole. So that hole looks like it's free now, so I can put my inductor in there. Good. So let's solder the new inductor with the LEDs visible, because hopefully once those legs solder onto the pads, then those LEDs should light up. Oh no, they won't, of course, because my positive battery lead is still not soldered. If I touch that onto there, then the LEDs light up. Why is that connection so bad? Why is it flickering? That was working well before. Or maybe I'll just solder it on. Perhaps it's just a bad connection. Right, let's just tin that. That should be tinned already, so that should solder on nicely there. Oh yeah, and that's working. Those LEDs are on. So yeah, that's fixed it. That can go back out in the garden, I think. I mean, you do have to ask yourself the question, is it really worth it? Because everything's so badly corroded. That switch no longer switches on and off. Is it worth fixing these things? But, you know, just from the point of view of trying to find out what the problem was. No, that screw won't screw up. Yeah, I think it is worthwhile, and that now works. Actually, that shouldn't work if I get light on the solar panel. No, it doesn't. So as I cover the solar panel, it turns the LEDs on, and when I let sunlight or very hazy, cloudy light onto that solar panel, yeah, it switches off. So the functionality looks like it's working well. Yeah, of course I haven't replaced that O-ring that crumbled away, so moisture is going to get back into this thing. Can't get my screwdriver onto there properly. Let's just reverse that back out because that didn't go in very well. No, it still isn't going in very well, was that? Bring it out and find a new thread. Oh, that's going in. Okay, I don't think this is exactly the right screwdriver for this. But yeah, anyway, that's gone in and the light's still on. And if I put some sunlight on the solar panel, it switches off. Brilliant, I'm happy. Right, there it is, fixed. So that comes on and switches off in daylight and comes on at night. And the problem was that the leg of this inductor had got so badly corroded. I don't know whether the these leads aren't copper, or whether perhaps copper corrodes. I don't know. These steel leads, and it just corroded so far that it broke through and the inductor was no longer connected into the circuit. With a new inductor, no idea really what the value of that new inductor was. It didn't look like the same color code as this, but anyway, any inductor seems better than no inductor. That's working, so that can go back outside. Yeah, so here they are, the 4 lights, and these 3 are all still not working, but this one now, if I block the light on it, works a treat. Fixed. Cheerio.